We talked last time about making a function table. So that was this slide where when we're given a linear equation, which is an equation that has two variables, usually x and y, and an equal sign, we can then make a function table and then graph that equation. The equation looks like a line, which is why it's called a linear equation. And when we solve, when we choose x's in our function table and then get y's that correspond to the x, those end up being points on the line. So these are our first three steps in graphing a linear equation. You'll be given the equation, you make a function table, choose three x values, so you can choose any three. Make sure that they're easy to graph and make sure that they make sense with your graph. So a lot of times you'll be given a graph or you'll have to draw a graph. And it's not going to be huge, so you're not going to want to choose values that are like, 10,000 or something, because that's not going to be easy to graph on a piece of graph paper. So values that are easy to graph, and then you plug in the x value, get a y value. So that's where we got to so far, and we practiced making function tables. So then we go to step 4, which is we're going to use the function tables that we made and plot them. Now the thing to realize here, and this is sort of what brings this all together, is that when we pick an x value, plug it into our linear equation, and get out a y value, that is technically an ordered pair. So the x that we chose, -1, corresponds with a y value, in this case 3, which is an ordered pair that's going to make up the line that we're going to end up creating that models this linear function. So we make our function table, and then we take each of those values, the x and its corresponding y, and make them into ordered pairs, right? And so we write ordered pairs, x comma y in parentheses. Then we graph each of those ordered pairs on our coordinate plane. So remember that to get to the ordered pairs point on the coordinate plane, first we take our x value, and that tells us which way to move horizontally. So starting at the origin, for our first point, we would move to the right, to the left, okay, -1. And then we would move up 3, 1, 2, 3. So our first point, we'd put a point right here at -1, 3. So I like to put the point, and then I like to label it. And I want you to do this too, so get in the habit of plotting the point on the graph and labeling what that point is. Okay, we'll do the same thing. Let me erase those. For the next point, which is 0, 1. So with 0, 1, we don't move anywhere horizontally, right? 0 is our x, so it's not going to go either way, left or right. And then we just go up 1 and plot that point at 0, 1. Okay, our last point is 1, -1. So we are going to move 1 to the right in a positive direction horizontally, and then down 1, so -1, to our next point. So then we put a point there and label it 1, -1. Once you've plotted your points, then now you can tell the points should look like they are making a line, right? This is a linear function. If you have some crazy point that, like, you did your math and you get a point like way out here that's not on the line, check your math, because it should be all on a line because it's a linear function. So make sure you didn't lose a sign or do your subtraction or addition wrong or something like that. So we plot each point, label each point, and then last step is to draw a line. So use a straight edge, a ruler, your ID card, a protractor that's got a straight edge, something that's got a straight edge so that you can very clearly and neatly connect these points. connect the point with a straight edge, and arrows. So you want to make sure that your points are connected, but they also have an arrow going, like the line goes through the points and continues, oops, I didn't mean to do that, continues past. So it keeps going. This line doesn't stop at these points, right? There are other X values and other Y values that are on this line. We just didn't choose to solve for those or to graph those, but the line keeps going. So you need to make sure that you have arrows in both directions in order to correctly show like how the line looks on the coordinate plane. Okay, so next we are told graph y equals 3x. So we're going to use all of our steps now in order to graph this function. Okay, so we're given the linear function, y equals 3x. So it's got an x and a y. It's got two variables. It also has an equal sign. So our next step is then to create our function table. Okay, create our function table, and we're going to graph these points. So choose 3x values that make sense. So I, as you know, like to choose -1, 0, 1. And then I like to plug in. You have to plug in each of those values for x in your original equation. So if we say y equals 3 times -1, we get that y equals -3. So we get -3 for y. I'm going to do all my math first, and then I'm going to plot my points. Okay, secondly, we'll say y equals 3x. If x is 0, we get y equals 3 times 0. And 3 times 0 is 0. So when x is 0, y is 0. And then last of all, when x equals 1, y equals 3 times 1. Y equals 3. All right, so next step, let's go ahead and plot these points. We're going to plot and label. So this first ordered pair is -1, -3. So we're going to go -1, so to the left, and then down 3. 1, 2, 3. So I'm going to put my point right here. I'm going to erase those little movement points, and I'm going to label my ordered pair, -1, -3. Okay, then my next ordered pair is 0, 0. That's the origin. So we will not be moving anywhere off of the origin. We're just going to plot that point right there at the origin, label it 0, 0. And then finally, our last ordered pair, 1, 3. So we go 1 to the right, start at the origin, go 1 to the right, and then up 3. 1, 2, 3. And that's where our point will go right here. Erase the red movement points. Fill that in a little bit. Okay, and then label my point, 1, 3. Okay, my last step is going to be to connect these points using a straight edge or a ruler, and making sure that my line goes through the points with arrows at the end, because that line keeps going past those points. This is a proper graph. When I ask you to graph for on graph paper, on a test, on a quiz, on a worksheet, I want 3 points plotted and labeled, connected with a line. On big ideas, when you do your homework, it's only going to need 2 points, because you only need 2 points to make a line. So with big ideas, you'll only need to do 2 points. But for me, on paper, 3 points plotted and labeled. All right, when graphing, we've talked about this. When a line, we saw this in our function table practice. If a function, linear function, has a fractional coefficient, so a fraction before the x, you want to choose, as we've talked about, easy numbers. So -1, 0, and 1 are usually easy numbers, but they aren't easy when you have a fractional coefficient, because then you end up having to work with fractions. You have to add fractions, subtract fractions. That's a pain in the neck. So in order to help us work with fractions easily, we want to choose for our x values numbers that are easily divisible by the denominator of that fraction. For example, if you're given this linear function, y equals 1/2 x minus 1, when you make your function table, you want to choose x values that are easily divisible by this denominator of 2. So our x values should be divisible by 2 easily, because when we multiply 1/2 by something like 4, right? Make that a whole number, 4 over 1, cross simplify, we end up getting a whole number answer that we can work with rather than a fraction, which becomes, number 1, a pain to do the math, and number 2, a pain to graph. So we want to choose numbers that are easily divisible by that denominator of 2. For example, I would choose, instead of -1, I would choose -2. I would still choose 0, because 0 is always easy. When you multiply a fraction by 0, you get 0. And maybe +2. Or maybe 0, 2, and 4, or something like that, because those are 2 and 4 are both easily divisible by this denominator of 2. So let's do the math with each of these. 1/2, if we use our first value here of -2, 1/2 times -2 over 1 minus 1. And I just changed that -2 and put it over 1 because it makes it easier to multiply that fraction. Cross simplify, this becomes 1, this becomes -1. If I do my multiplication, -1 times 1 is -1, and then minus 1. So we get y equals -2. So my first ordered pair is going to be -2, -2. Let's plug in 0. If x equals 0, y equals 1/2 times 0 minus 1, which is 1/2 times 0 is 0 minus 1. So y equals -1. And finally, let's plug in our +2. Y equals 1/2 times 2 over 1 minus 1. Cross simplify here, and we end up with y equals 1 minus 1. Y equals 1 minus 1 is 0. Okay, so these are our ordered pairs here. -2, 2. I'm going to rewrite them over here and copy them onto my next slide. -2, comma 2. 0, comma, -1, and 2, comma, 0. So then, now we've got our ordered pairs. And we're going to move to our graph. So if I plot those ordered pairs over here, we've got -2, 2, 0, 1, and 2, 0. So let's start with -2, comma 2. That's up here. So first we go to the left 2 and then up 2, and then label -2, 2. My next point is here, or not at the origin. It's at 0, -1. So that means I'm going to not move left or right because it's 0. I'm only going to move down 1. So it's right on the y-axis. Label 0, comma, -1. And lastly, 2. So I'm going to go to the right 2. And then up 0. So something went wrong with my math. I'm going to keep this in my video because I want you to see, because this could happen to you. Okay. So notice this doesn't look like a line. So I have done something wrong with my math. I'm going to go back. Some of you probably have already noticed. If you're watching the video, you probably saw where I went wrong, but I didn't see it. So I'm going to quickly go back and check my math. Let me erase this. Oops, erase. I'm going to just pause and work for a sec. Okay, I think I found my error. I think it was in my ordered pair. This should not be negative 2, 2. I forgot a negative sign here. It should be negative 2, negative 2. So I'm going to go back to my graph, and I'm going to erase this. This was not correct. I'm going to add my negative sign in here, and I'm going to replot this point. This should be at negative 2, negative 2. So down here. And that now looks more like a line, negative 2, comma, negative 2. Now this looks like these are all in line. I can use a straight edge, making sure my line goes through the points with arrows on either end. This looks correct. Okay, the reason this was easy for us to graph is because we chose good X values that got rid of those fractions and made our math easy, number one, and made our points easy to plot. All right, the graph of y equals a number, so where there's no X in the equation, y equals a number. For example, y equals negative 3. Notice how it's just y equals a number. There is no X here. Okay, you will see this on the homework. Don't forget. Everybody always forgets about this. And then they're like, what should I do? Well, this is what you should do. So what we're going to do is remember that when we have just a y equals a number, you're going to have a horizontal line that crosses the y-axis at negative 3. Oops, I'm going to go back. So when it says y equals negative 3, we cross the y-axis at negative 3. And it's going to be a horizontal line. Because what this is saying is that no matter what your x equals, y always is going to equal negative 3. So it's like, doesn't matter what x is, y is always negative 3. So it makes a horizontal line crossing the y-axis because y equals negative 3 at negative 3. Okay, if you're doing a horizontal or a vertical line, I don't need to see multiple points listed. I just need to see the correct line crossing the axis at the right place. Try this one. Y equals positive 5. So if we plotted positive 5, we know that there is no X in this equation, right? No X in this equation, so we know it's going to cross the y-axis at positive 5. No matter what x equals, y is always 5. So our line is going to look horizontal, crossing the axis at y, the y-axis at positive 5. Okay, one more. If y equals negative 2, we know that this will cross the y-axis. It's going to be a horizontal line. No matter what x equals, y always equals 2. So it's going to make that horizontal line crossing the y-axis because y equals negative 2. Okay, conversely, if you are given an equation where you only have an x and no y, then the opposite thing is going to happen. Instead of crossing the y-axis at that number, it's going to be a vertical line crossing the x-axis at the number you're given. So if x equals 2, we hit the x-axis at positive 2, and no matter what y equals, x always equals 2. So we're going to have a vertical line in this case, crossing the x-axis at the number we were given. Okay, if you see something like this, x equals negative 1.5. Now, looking at our coordinate plane, we don't have a 0.5, so we need to use what we know about numbers and recognize that negative 1.5 is going to be right in between negative 1 and negative 2. So it's going to cross the x-axis at negative 1.5, and no matter what y equals, x will always equal negative 1.5. So it's going to make a horizontal line. Okay, let me finish this little arrow. Okay, vertical line crossing the x-axis at negative 1.5. Last example, just to make sure that we've got it down. If x equals 6, there's no y in this linear equation. It's still going to be a line, but it's going to be a vertical line, vertical, up and down, crossing the x-axis at 6. Because what it means is that no matter what your y equals, x is always going to equal 6. So all your ordered pairs have to have an x as 6, okay? So vertical line crossing the x-axis at positive 6, and we just barely made it on this graph. All right, here's an example. Real world, this is how we can use linear equations to model the real world in real life. So here's what it says. The wind speed of a tropical storm is modeled by the equation 2x plus 66. When you have a word problem, a real world word problem, find the linear equation. So they're going to tell you it's modeled by this linear equation. That means this line, whatever it might look like, is going to be what the wind speed of a tropical storm looks like. So find that linear equation in your word problem. Okay, because it will be, sometimes it's embedded in a lot of words, but that's super important information to be able to solve. All right, so here's what it says. Y represents wind speed, and X is the number of hours after the storm enters the Gulf of Mexico. So on our graph, whatever our Y equals is going to be the speed of the wind. So when we get a Y value, that Y means how hard the wind is blowing. And X is representing the hours, so however many hours it's been, time, after the storm comes into the Gulf of Mexico. And let's see what they ask us. Also, on big ideas, always look at the little graphics that they give you, like off to the side or next to the word problem, because sometimes there's important information in the graphic. For example, a tropical storm becomes a hurricane when the wind speeds are at least 74 miles per hour. So this is probably going to tie into what they ask us to find in the end. So pay attention to the graphics. Here's what it says. Graph the equation. Okay, we need to graph this equation, y equals 2x plus 66, over in our little graph. This is going to be a little tricky. We need to think about this graph. So if we know that y equals 2x plus 66, we can still draw a function table, okay? But we need to think about a few things. First of all, what x values are we going to use? Hours after the storm enters the Gulf of Mexico. Remember, that's what x equals. We're not going to probably want to use negative numbers for x, right? We're going to probably want to use positive numbers only for x. So let's do a 0. So let's see what the wind speed is 0 hours after it enters the Gulf of Mexico. Let's do maybe a bit more spread out here. Maybe let's do like 2 hours and maybe like 5 hours, just to get an idea of what's happening with this storm after a prolonged period of time. So after 0 hours, we would do y equals 2 times 0 plus 66. 2 times 0 is 0 plus 66. So after 0 hours, like right when it enters the Gulf of Mexico, the wind speed of the storm is at 66 miles per hour. So is it a hurricane yet? If we look down here, well, no, it's still only a tropical storm level wind, okay? Next, let's see after 2 hours what happens. So y equals, 2 times 2 plus 66. So 4 plus 66, which is 70. So now y equals 70 miles per hour. Is it a hurricane yet? No. So still after 2 hours, it has not gained enough wind speed to be classified as a hurricane. So let's see what happens after 5 hours. Y equals 2 times 5 plus 66. So 10 plus 66, 76. So now our y is 76. The wind speed after 5 hours after entering the Gulf of Mexico is 76. Now, I'm going to copy this and move it to our next slide so that we can graph over here. All right. Now, to graph this, we just want to make sure that we label our graph appropriately. I'm actually going to erase this graph and put it. The reason that I changed this graph is because we don't need any negatives, right? We talked about that. We don't have negative numbers of hours that we would plug in for X, and we also don't have negative wind speeds. So it makes sense just to use the first quadrant, right? To use, the vocabulary here to graph this, because we only have positive X's and positive Y's. So down along our X-axis, this represents hours after entering the Gulf of Mexico, and our y-axis is going to represent wind speed. So now let's just label a couple points along our axis. I'm going to go every maybe couple, let's do, this is 1, 2, 3, 4, 5 hours, and this is still at 0. And then my y-axis doesn't have to be the same as my x-axis. Okay, notice how much bigger the numbers are in my y-axis. So I could actually go by maybe 20s or something. 20. Actually, let's do, I'm going to do this little scratchy thing in there between 0 and 20 because I'm not going to count all those smaller numbers. I'm going to basically skip and start at 20, 25, 30, 35. I don't know if I'm going to have room here. 40, 45, 50, 55. Oh, goodness. I'm going to redo this. Scratch. Okay, I redid it. I still use my little scratchy part, and I went by 5s, starting at 40, 45, 50, 55, 60, 65, 70, 75, 80. Now I can graph these points. So our first point is here at 0, 66, which is going to be just a tiny bit above 65 on our graph. And then we have 2, 70, so I'll go 2 to the right and up 70. And then 5, 76. So that's going to be just a little bit above 75. So now I can see how my equation looks. Oops. Equation. When it's graphed, okay? I do not have to connect these points, but I could if I wanted to. So if I wanted to sort of see with a line the behavior of a storm, right? We can see that as the time passes, the storm is going faster and faster, right? The wind speed is increasing. Here's what they ask. Let me erase. No. Let me go back here. It's not what I meant to do. Okay, let me go back. There's my line. And then when we look at the question, it says, when does the storm become a hurricane? And if we look back at the previous slide and the question that it asked us, it said a storm becomes a hurricane when the winds reach 74 miles per hour. So if we sort of draw a horizontal line across from about 74, maybe somewhere maybe a little bit higher than that, maybe dang it. Let's do this with just my free hand. Somewhere around here, right? So look at where it intercepts this line. Where it intercepts our blue line that's modeling our function is right at about 4 hours, right? It gets to 74 miles per hour at right around 4 hours after entering the Gulf of Mexico. Okay, so that's how we can use a linear function for a real life application. We know that this storm is being modeled by this particular set of data. So we can use that to predict, well, after 4 hours, it's going to be a hurricane. All right, that's it for this lesson.